Alright, in this video I have the level I exported on the PC up and running on the iPhone. And despite the hundreds of draw calls and the texture switches, because I'm not using a texture atlas, it runs surprisingly well. There's enough left over for the GPU and CPU so that I can actually do the game AI, the animation, and any CPU side processing I need for the game, and still hit the performance targets. For instance, this runs at 60 frames per second, and again, I have tons of draw calls, there's no batching, and a lot of texture state switches. So I guess we can say that the iPhone has what I would call a slop barrier. So you can get pretty sloppy and still get reasonable performance. So that's a good sign, because when I actually do texture atlasing and instancing and batching, I'll get an instant performance boost, and it really won't take much effort. The only thing that's optimized with this render right now is the visibility determination's fairly quick and easy to determine which objects are visible and which are not. And as you can see, it's up and running. And like I said, I'd have an overhead view to maximize the draw calls, and also so I could see the level and make sure it's accurate to what I had on the PC. Now, if you're wondering why I have the tools on a Windows PC for the iPhone, as opposed to, say, having the exporter and the level editor running on the Mac, the reason's pretty simple. The artists I work with, or will be working with, they work on Macs, or sorry, they don't work on Macs. That's the problem. They work on the PC exclusively. All their software is for Windows-based PCs, and they're just not going to spring for new software and new hardware just because I'm doing something on the iPhone. So I said, fair enough. So the tools are written for the PC. However, they're portable. I use Qt for the level editor, and I have a OpenGL render backend, so it wouldn't be very difficult for me to port it to the Mac. But again, the artists work on Windows. Despite what I have up and running here, I'm not finished with some optimizations, with all the optimizations for that matter. One thing I'm going to do is CPU side occlusion culling. And for those that don't know, occlusion culling is, for example, let's say there's an object behind the wall and the camera is looking straight at the wall. With occlusion culling, you'll be able to determine that that object is behind the wall is completely obscured, and you won't send it down to the GPU for processing. So you'll be able to detect things that shouldn't be rendered. It's more than visibility determination, because the object that's behind the wall is actually visible to the camera. It's just that there's a wall in front of it. So that type of culling using frustum won't help you in this regard, but the occlusion will. Now, the way the GPU is architected for the iPhone, it has pixel perfect hidden surface removal. So when it comes time, and it's pixel perfect. So even if you were to send that object, the pixel shaders to light the object that's hidden behind the wall will not be activated. The GPU will take care of that. However, despite that, it's still an optimization in saving a draw call and having the GPU determine whether the object should be lit with the pixel shader processing by having the occlusion call. It just gets rid of unnecessary processing on the GPU side. And it's also an advantage to do it on the CPU for those phones that don't have hardware occlusion culling. I'm going to support both hardware and CPU based occlusion culling. And another thing I'm going to have, if you see these columns of cubes right here that I'm pointing at with the mouse, and here's another column and another column here, and for instance these cylinders is another example. Each one of those right now is an individual draw call, which of course is not optimal. So one thing you could do is you could optimize this by welding all these meshes together. However, that'll reduce the draw calls to only one, but let's say these 4 golden cubes are visible and these gray ones are not. Well, you're still sending the 4 gray ones that aren't visible to the renderer or to the GPU. Again, the GPU will determine that these 4 cubes that I'm pointing at, the light gray ones here, are not visible, and it won't it won't render them or, run the pixel shader or whatnot. However, it would be great if they weren't even considered, like, if they weren't even part of what the GPU would need to process. But since it's a static mesh, you can't really, you can't really have a say with that. So what I've come up with is something called dynamic static batching. And what I do is I have a global vertex buffer for all the objects, so for all these 8 objects that I'm pointing at. However, if only the top 4 gold ones are visible, what I do is I dynamically modify the index buffer to only have those 4 objects in the index buffer. The lower 4 dark gray cubes are not in the index buffer. So when I send that down to the GPU, it's still one draw call, but those 4 objects that aren't visible in the static buffer are not even there, so the GPU doesn't have to consider them. And for example, if they were all visible, these ones that I'm pointing at, then I would again dynamically update the index buffer to include all the visible objects. So that's just an optimization that I came up with. It may or may not work, but it's worth a try, and especially if it avoids processing unnecessary objects on the GPU. I'm going to do some little tricks in order to have the ability to update the index buffer dynamically on the CPU and not have it interfere with GPU processing. And another thing, it's probably going to be run as a threaded job where I just throw a thread job to the thread pool and say, update the index buffer. This is what's visible. So just process the index buffer with what I need, the data that I need. And that's pretty much all I have to show right now. As you can see, the editor has exported the data and it's been loaded correctly by the iPhone, and it's running at pretty good I was really surprised. I thought it was gonna be substandard, maybe less than 30, but no, it's running at 60. The iPhone can surprisingly handle sloppy rendering for now. So till next time, this is the video of the editor. Thanks and bye.